In today's lesson, we are learning about another property of logarithms, the quotient property. So we've already done the product property. Product corresponds to addition, and now we're going to get into the quotient property. All right, so quotient means division. So the property is if you have log of a base x, and then it's of a divided by b, that would be the same as log base x of a minus log base x of b. Okay, so you can use that property to both expand or condense logarithms. So for the first example, if we have log base 2 of the fraction 5/6, or of the quotient 5/6, that is equal to log base 2 of 5 minus log base 2 of 6. And now, backwards, we will take two logarithms and condense it into one. So that example, I have log base 3 of x minus log base 3 of 4. We can condense that into one logarithm, log base 3 of x over 4. Just like the last property, I am splitting them up into the part A and part B. So if you remember, part A is when your logarithms are on one side of the equal sign. So first example, start easy and then we'll get a little more difficult. So log base 5 of x minus log base 5 of 3 equals 2. So we're going to start two logarithms we need to condense into one using the quotient property. So this will be log base 5 of the fraction x over 3 equals 2. Now, after we condense, we need to convert. Convert to exponential form. So that's base 5 to the power of 2 equals the quotient x over 3. All right, so let's keep going. 5 squared is 25. So 25 equals x divided by 3. To solve for x, opposite of dividing by 3 would be to multiply by 3. So x equals 75. All right, so we are still in part A, but it's a little bit more difficult question now. So log base 3 of the binomial x plus 25 minus log base 3 of the binomial x minus 1 equals 3. Okay. First step is to condense into one logarithm using the property. So we have subtraction, so that will condense into log base 3 of the quotient x plus 25 over x minus 1. I don't need those parentheses, but it doesn't matter if they're there. Once you condense into one logarithm, then you convert. Base 3 to the power of 3 equals that quotient. So let's write that down. 3 to the third equals x plus 25 over x minus 1. Okay, so this might look a little scary, a little confusing, but it's not too bad. Over here, to get rid of this fraction, I can multiply by the binomial x minus 1 on both sides. because that will cancel my denominator out. And then over here, all I have to do is distribute this 3 to the third, which 3 to the third is 27. So 27 times x, 27x. 27 times 1 minus 27 equals my numerator, x plus 25. Now to solve for x, I just need to get my x onto one side. So I have 26x minus 27 equals 25. So I add 27, add 27. So 26x equals 52. Now divide by 26. Divide by 26. So x equals 2. All right, now 2 examples, part B. Part B is when you have logs on both sides of the equals. All right, so our example is log base 4 of 30 minus log base 4 of 5x equals log base 4 of 6. First step is always the same. Condense the logs into a single logarithm. So this will be log base 4 because of subtraction. I can create that quotient 30 over 5x equals log base 4 of 6. So if log 4 equals log 4, then we can drop the log and just set an equation with what's inside. 30 over 5x equals 6. Okay, so to get x by itself, we can multiply both sides by 5x because they will cancel here. Get the x out of the denominator because we don't like it there. So 30 equals 6 times 5 was 30x. So x has to equal 1. All right, last example for part B and for the whole lesson. So log of 50 minus log of the binomial x plus 2 equals log 9. So remember, if I don't write a log, it means, if I don't write a base, it means log base 10. Just a reminder. It's not actually important in this question, but always reminding. All right, condense. So log of 50 over x plus 2 equals log of 9. So after it's condensed, logs on both sides, we can just set this equal to this. So 50 over x plus 2 equals 9. Let's get our variable out of the denominator. So I'm going to multiply both sides by the x plus 2. Cancels out. So now I have 50 equals, I'm going to distribute 9x plus 18, and now just finish solving for x. So minus 18, minus 18. So 32 equals 9x, and now divide by 9. We'll end up getting a decimal for this one. We can just leave it as the fraction 32/9. So there is your full lesson on solving logarithms using that quotient property. Good luck.